All right, so last topic in this section 1.1, 1.2 sort of review, and that's function transformation. So first thing is vertical shifts. And so you start with your function f of x, and you add or subtract a constant c. Let's say let c is a real number. Okay, so f of x plus or minus c. This is a vertical shift up or down by c. I'm being redundant because vertical, up and down, whatever. But the point is, we can do an example. So I'll just do a quick example of each one of these. Let's consider the function f of x equals x squared minus 3. And so you say, oh man, that wasn't one of the ones that we talked about. Wait a minute, I understand that the graph of x squared, I can graph that. So I'm going to quickly sketch x squared. In my mind, I know that x squared looks like this. And then I realize the minus 3 means just shift it down 3. So I'm just going to go down in my mind 1, 2, 3, and then I'm going to draw that same function just like that. So vertical shifts are pretty easy to recognize. It's just your function that you know, add or subtract a number, and that's literally shifting you. Here I think I can actually copy and paste. Whoop, not quite. It's quite literally shifting you up and down. I'll just do this part, but the whole thing should be moving, but I can't do that. So vertical shifts, easy to recognize and relatively easy to graph. All right, let's talk next about reflections. And there's two kinds of reflections. There's vertical reflections, and there's horizontal reflections. But in general, reflections are easy to recognize because they involve a negative. So vertical reflections are when you just look at minus f of x. And this is a reflect over the x-axis. Okay, so an example of this would be f of x equals negative x squared. Let me shift this down. Speaking of a vertical transformation, we'll just slide that down. So I want to graph the function minus x squared. That wasn't one of the ones that we talked about in our list of key functions earlier, no problem. I know what x squared looks like. In my mind, I'm going to visualize x squared up here, and then the negative I realize means it's a vertical reflection. Flip it over the x-axis, so the graph of a minus x squared looks like that. No problem. All right. Horizontal reflections, let's erase the s there. Horizontal reflections are when you have f of minus x, okay? And these reflect you over the y-axis. So let me give you just a classic example of this. You might have g of x is root minus x. Okay, whoa. So there's a negative inside the function now, but you recognize, okay, that's just a horizontal reflection. How do you actually go about graphing a function like this? Well, in your mind, you sketch the old graph, right? Root x looks like that, and now you just flip it over the x-axis, and it looks like that. That was not a very nice graph. Let's try that again. Something like that. Okay. So reflections, you just have a negative either outside your function or you're plugging it inside onto all the input values. You're reflecting them, making them negative, and it either flips you over the x-axis or over the y-axis. Finally, last one, I want to look at one more kind of transformation with you. Let's look at, let's just call this vertical scaling. Okay, and so this is going to look like some constant c times f of x. And so here's the idea. Let's just actually do an example of this just to see it. I think that we can do this with a quick example. If I have f of x equals x squared, and I have, let's say, g of x equals 1/2 x squared, and I have h of x equals, let's say, 5x squared. Maybe we'll change the color on h. Let's make h, I don't know, green, let's make G, let's make it, I don't know, blue. Okay, so what's happening on these vertical scaling is you can graph each of these. So let's just say this guy is x squared. These are not perfect graphs. It's all in relation to each other. All right. When you look at h of x, the 5, when you multiply by a number bigger than 1, it's going to stretch you vertically. You're going to get bigger faster. So 5x squared is going to actually grow vertically quite a bit faster than the original f. Whereas 1/2 x squared, you're multiplying by a number less than 1. That's going to grow slower, right? All the outputs are cut in half, so that's going to look a lot flatter. That's supposed to be blue. Hopefully you can see that as blue. It's going to look a lot flatter and look like that. So what's the summary? So CF of x is it's a vertical stretch when the absolute value of C is bigger than 1. Because, by the way, C could be negative, and then you have a reflection and a stretch combined together. And CF of x is a vertical shrink when the absolute value of C is less than 1. Of course, we don't want to consider the case when C is 0, because that completely wipes you out. So maybe we should actually add that up here to our little list. We should say C is not 0. All right, well, there you have it. That's the review that I typically cover for this material. You should have all that you need now to go over the homework. I'll just say that I've posted some other review materials, so if you maybe have forgotten things like factoring or just other basic algebra skills that we're going to need, please look on Campus Web or Teams, and I've got a lot of resources available. So don't be afraid to reach out. We've got a good tutoring lab here at the college where you can get some help as well. So dive into your homework, and we will be in touch soon.